All right, let's start talking about the graph of the cotangent function. So when we did the graph of sine and the graph of cosine, we looked at some animations. We didn't do the same thing with tangent because tangent, it wouldn't have worked out as nicely, and it would have been better to go a different route. So with tangent, what we did is we looked at the asymptotes and we plotted some points. We can do the same thing with cotangent, but let's do something a little different again. So what I want to do is first graph y equals tangent of x. Okay. So we'll set up our x-axis, our y-axis. So we're not going to go through it again. We're just going to put the graph down, just one complete cycle. Okay. So vertical asymptotes at x equals positive pi over 2, and another one at x equals negative pi over 2. Okay. So that's x right there. All right, and then the graph had that shape kind of sort of like this. So this pretty bad drawing, but could be worse, I guess. All right, so anyway, it had that general shape right here. Kind of like y equals x cubed, but not exactly like it. So anyway, it has this kind of thing here. So this is y equals tangent of x, okay? All right, now what I want to do, set aside some space here. Now what I want to do is I want to shift it a little bit. So what I want to do is now graph y equals tangent of x plus pi over 2. Okay, tangent of x plus pi over 2. So how does that shift it? Well, remember, it's just like in pre-calculus. If you had the graph of a function y equals f of x, so remember, like if you did f of x plus 1, that would shift it up 1 unit. Or if you did like f of x minus 2, it would shift it down 2 units. But then if you put it on the x inside, that would be different. So remember, f of x minus 2 like this, that shifts it to the right by 2 units. Okay, so remember the x behaves kind of backwards from how you would expect. And then x plus 2, that would shift it to the left by 2 units, okay? So even though we're talking about trig functions here, all these rules about transformations, all the same ones still apply. Okay, so tangent of x plus pi over 2, that's going to take this tangent of x and then shift it to the left by pi over 2 units. Okay? So that's going to happen here. Now I do want to point out that because of the periodic properties of tangent, it's actually going to be the exact same thing, but that's just a happy or maybe unhappy coincidence that it works out like that. So we do want to be really careful. But anyway, that's only because the tangent has period pi. So shifting to the left or to the right, pi over 2 units in this case won't make a difference. This specific case here, but I just want to point that out. That's not true in general, so be very, very careful. In general, this just means shift, it always means shift to the left, okay? So just be very careful about that. So this plus, so x plus 2 would mean shift to the left by 2 units, always, always, always. Okay? So tangent of x plus pi over 2, shift this to the left by pi over 2 units. So let's go ahead and draw that. Okay, so we're going to take our graph that we have here, maybe zoom out a bit, and then shift it to the left by pi over 2 units. So here is going to be our x-axis. Here's our y-axis. Move that over a little bit. X, y. Okay, so now the asymptotes are going to move with it, which is kind of nice because that kind of helps us. It gives us a little guide to work with. So if we take x equals pi over 2 and move it to the left by pi over 2 units, where does it go? Well, pi over 2, subtract pi over 2 units to go to the left, and we're going to be at 0, right? X equals 0. So actually we have a vertical asymptote right here on the y-axis where x equals 0. Oh, that's nice, I guess. Okay, what about this one? X equals negative pi over 2. Well, if we move that pi over 2 units to the left, where's that going to go? That's going to go from negative pi over 2 minus pi over 2 more units. So that's going to be negative 2 pi over 2, which is just negative pi. Okay, so if you're at negative pi over 2 units, subtract pi over 2 to go to the left. So going to the left, pi over 2 units. So remember, plus pi over 2 means shift to the left. And then to actually figure it out, we have to subtract to get there because we're going to go in the negative direction. So x equals negative pi is going to be the other vertical asymptote. Okay, so this is x equals negative pi. Okay, so that's our other vertical asymptote there. Let's maybe fix that label. X equals negative pi. It's a tiny bit better. Okay, so x equals 0 and x equals negative pi. Those are our two vertical asymptotes. So take these vertical asymptotes, shift them to the left, pi over 2 units. You get these vertical asymptotes. And then we got to remember that this graph moved with it. Okay, the whole graph moved with it. So let me maybe change my x-axis so that I actually have relatively the same amount of room on the top and the bottom. So put the x-axis about here. X. Okay, so now when we put the graph in there, it's going to kind of sort of be something like this. Oh, that's terrible. That is just awful. Okay, so this point up here, so that's terrible. This point up here was 0, right? So if we move everything to the left, pi over 2 units, this is now negative pi over 2. Okay. And just in case you have a thought for a brief moment, oh, what, I thought we have asymptotes there. Remember, everything's shifted. Okay, when we do tangent of x plus pi over 2, everything shifts, including the asymptotes. Okay, so the graph itself, the asymptotes, they all shift together. Okay. All right. So one more thing to do, and then we'll talk about. Then we'll see why we're doing what we're doing. So remember, the goal here is to get the graph of the cotangent function. So we'll see why we're doing this. We're going to get there eventually. So I want to set off some more space here. All right, so I have y equals tangent of x plus pi over 2. Now what I want to graph is y equals tangent of negative x plus pi over 2. Okay, so what I want to do is put a negative sign on the x. So it's going to be the exact same thing as this. Maybe let's label this graph. Y equals tangent of x plus pi over 2. Okay, just to be thorough. And then, so I'm going to take this this thing here, and then I'm going to put a negative sign in front of the x. So that's the only difference here. Okay, so tangent of x plus pi over 2, tangent of negative x plus pi over 2. So remember from your pre-calculus or college algebra days, what does that do? If you put a minus sign in front of the x, that's going to take your graph and reflect it over the y-axis. Okay, it's reflect over the y-axis, so be careful about that. It's not reflection over the x, it's reflection over the y. So we got to watch out for that. So basically what we're going to do is take this, and then because we put a minus sign on the x, we're going to reflect this over the y-axis. Okay? So let's go ahead and draw that. So we'll set that up here. Here's our x-axis. Same amount of room on the top and bottom, y-axis. Okay, so if we take this whole thing here and reflect it over the y-axis, let's just look at one piece at a time. So where does this vertical asymptote x equals negative pi go? Where does that go? Well, if we take x equals negative pi, reflect over the y-axis, that's going to become x equals positive pi, right? So just imagine taking this, folding it over, and then leaving an imprint here. X equals negative pi becomes x equals positive pi. Okay. Okay, so that's one asymptote there. So this is x equals positive pi. Okay, and then x equals 0, well that's right on the y-axis, so if you reflect over the y-axis, then anything on the y-axis just stays there. Okay, so if you reflect over something, anything that's already on that thing just stays there. Okay, so again, reflect over the y-axis, but this is the y-axis, it's on the y-axis, so it stays there. So x equals 0 just stays where it is. Okay, so that's x equals 0 right there. Okay, so there's the asymptotes. Now what about this? So when we reflect over, so now we take this and reflect it. So be careful, it's not going to actually have this shape, right? Because that's not a reflection, that's going to be a shift. But if we take this and reflect it, it's actually going to be going down like this, right? So take this, reflect over the y-axis, it's going to have this shape here. So it has to come down like that. So it's really like a mirror image, right? That's why I keep saying reflect, because we reflect over the y-axis like a mirror image. So take this, flip it, or just imagine like in a mirror, it's going to come down like that, okay? So coming down like this, and I'm just even worse at drawing it like this. All right, let's maybe go this way, start down here and come back up. Oh, what a disaster. Terrible. All right. I mean, I can try that all day and it's not going to get any better. So anyway, if this was negative pi over 2 and we reflect like that, this is going to be what? Positive pi over 2, right? just like here, x equals negative pi, reflect and we get x equals positive pi. Take negative pi over 2, this x-intercept here, reflect it, and we get this x-intercept positive pi over 2. Okay, so what's significant about this? Well, remember that thing we talked about a really long time ago? What was it called? It's called the complementary angle theorem. So remember what the complementary angle theorem says? Complementary angle theorem. Okay, the complementary angle theorem, it told us that sine of pi over 2 minus x equals cosine of x. And it said that the secant of pi over 2 minus x equals the cosecant of x. But the relevant piece here that I want to point out is the tangent of pi over 2 minus x equals the cotangent of x. Okay, well, how's that relevant? Well, let's come back up here and take a look at this. Tangent of negative x plus pi over 2. Well, negative x plus pi over 2, that's the same thing as pi over 2 minus x. So inside of the tangent, I can change that and write it like this. So negative x plus pi over 2, that's pi over 2 minus x. Tangent of pi over 2 minus x. Remember, the complementary angle theorem says that tangent of pi over 2 minus x is cotangent. Okay? So actually, right here, tan of pi over 2 minus x, that's cotangent. Tan of pi over 2 minus x, that is cotangent of x. Okay? And that's why I went through all these transformations here, so that we can, shift and then reflect, so that we can actually get this and use the complementary angle theorem. Okay, so it's a little bit different. It's different from how we did sine and cosine. It's different from how we did tangent. So it's always nice to see new ways of doing things. So anyway, this is y equals cotangent of x. Okay? And just like with tangent, cotangent also has the same periods, period pi. So it's going to repeat. Okay, this piece right here repeats this way, infinitely far to the right, repeating if you just keep going. So 0 to pi, it's this piece. Pi to 2 pi, it's the same piece. 2 pi to 3 pi, it looks exactly the same. 0 to negative pi, it looks exactly the same, and so on and so forth. Okay? And again, how do we get there? Well, we started with tangent. We shifted to the left pi over 2 units. We got that. Then we reflected over the y-axis with this negative in front of the x. And then we used the fact that, well, negative x plus pi over 2, that's pi over 2 minus x. Tangent of pi over 2 minus x is cotangent from the complementary angle theorem that we talked about several videos ago. And then that's our graph here. So what if we want to graph several? So we'll end the video by graphing several pieces. So x-axis, y-axis. So let's put some vertical asymptotes in here. Pi, 2 pi. Maybe you should space those out a little more, but it really doesn't matter. So this is x equals pi, this is x equals 2 pi. This right here will be x equals negative pi. Zoom in a tiny bit. And then this right here will be x equals negative 2 pi. Okay. So this piece we saw up here, remember, went down like that. So let's put that piece over here again. So another disaster coming up. Yep. Oh, and we also had a vertical asymptote here at x equals 0. Okay, so this piece right here is the same as this piece up here that we already drew. So that's this piece right here. And again, because it has that period pi, so this right here is pi over 2. It has that period pi, so every pi unit is going to repeat. So it's going to have that exact same shape right in here. Or if I knew how to draw any better, it would be the same shape. So pi over 2 plus pi is 3 pi over 2, right? And then what about right here? Same exact shape. I should not be allowed to do that. Okay, negative pi over 2. And then same exact shape here is going to be negative 3 pi over 2 right there. Yikes. Okay, so that's negative 3 pi over 2. Okay, so this is, and it's going to keep repeating infinitely many times this way, out to the right, and out to the left. So this is y equals cotangent of x. Okay, Now, just some other things I want to point out real quick. Remember, cotangent of x, that is cosine of x divided by sine of x. Okay, and what do we see if we look at the graph? We see that cotangent of x is 0 when cosine is 0. Okay, things like this are 0 when the top is 0. Okay, the top is 0 at pi over 2, negative pi over 2, 3 pi over 2, negative 3 pi over 2, and so on. Cotangent has vertical asymptotes when the bottom is 0, when sine is 0. Sine is 0 at 0, pi, 2 pi, negative 2 pi, 3 pi, negative 3 pi, 4 pi, negative 4 pi, and so on and so forth, right? So, just like with the tangent function, there's vertical asymptotes when the denominator is 0. There's x-intercepts when the numerator is 0. They just happen to be at different values of x, okay? But it's just the same thing in general. X-intercepts when the top is 0, vertical asymptotes when the bottom is 0. Okay, but we'll talk about that more in the next video when we talk about the properties of cotangent. But anyway, this is the graph of cotangent and one of the many ways of obtaining the graph and seeing how it looks. Okay.